If I am asked to write a function to sort an array, probably I'll write a function called sortInts, which can be called by passing an integer array as parameter. But have you ever thought, can I use the same function to sort an array of floats or array of doubles or array of strings? To get this answer, we have to talk about the concept called function overloading, or aka sometimes it's known as method overloading, coming right up. Hey, this is Subrata Kumar Dey. I am a university teacher teaching computer science courses over 1.5 decades. If you are a coding enthusiast, consider subscribing this channel and press the notification bell so that you don't miss anything. Okay, so if we implement an algorithm, a set of logic to do something on a data or a set of data, then we write the function with the parameter types and we send appropriate type to call that function from the caller, where caller also is another function. But the problem is, even though the logic can be same, even though the algorithm can be same, the same function cannot be used for different data type. For example, as I was talking about the sorting integer array, I can write a function called sortInts, where the parameter can be integer array, a reference to integer array, but I cannot use the same sortInts to sort an array of floats. Therefore, I have to write one more function called sortFloats, where the type will be reference to float array, so that I can call the sortFloats function by passing a float array as parameter. Now you see, the problem is, if you want to deal with 10 different types of arrays, then you have to write 10 different functions with different names. Irony is, the underlying logic of each of those functions are same. They are doing the same thing, sorting an array. But because the data types are different and we want to use different types of arrays to be sorted, then we have to provide 10 different functions with 10 different names to deal with 10 different types of arrays, even though the working mechanism of all the functions are same. Is that a problem? Of course not. Syntactically, that's absolutely fine. But that sometimes become inconvenient for programmer. If I have so many functions with so many different names, sometimes it becomes difficult to manage them, or at least inconvenient. It causes inconvenient to me as a programmer to write to call different functions at different context. So to get rid of this problem, or in other words, to facilitate the programmer, there is something called function overloading is provided. What it means? When we say a function has a designated task to do, technically it means it has a definition, it has a body, and whenever the function is called, that definition gets executed. That's what the function is normally supposed to do, because that's the normal definition that function is associated. However, we can actually define multiple definitions of a particular function. For example, instead of creating different functions with different names such as sortInts, sortFloats, sortDouble, etc., we can simply give one name, that is sortArray, and provide multiple versions of the definitions of sortArray. One will be with integer array as parameter, another will be float array as parameter, another will be double array as parameter, and so on. And that actually gives me the flexibility to use a single name to sort different types of array. Isn't it fascinating? Yes, of course. But there is a catch. The catch is each of those definitions must have unique parameter list. So the signature of those definitions must be unique. Okay, they can be unique in terms of type of the parameter. If there are multiple parameters, then the sequence of types can differ, the number of parameters can differ, also the orientation of the parameter can differ. So in any way or combination of these the parameter lists must be unique, and then only we can actually provide multiple definitions of a particular function, and therefore function overloading will be achieved. So this is nothing but an advantage at the disposal of the programmer. Okay, why the parameter list has to be unique? Because suppose we have a function called void do sum, parameter is int. Okay, and the definition, now we have another definition of do sum, let's say void do sum, now the parameter is float. So we have two different definitions of do sum, one with integer parameter, another with float parameter. Now as a caller function, suppose main function calls do sum by sending x as parameter, suppose x is an integer, now it will match with the definition with integer parameter. So it can conclusively identify the definition to pick for execution, and so there is no confusion. But if what if both the definition has integer parameter? Now if you call the do sum with integer parameter x, then compiler get confused which definition to choose for execution. And that is why we are not allowed to overload a function if the parameter list are same for both the version. Okay, so that's the requirement. Return type can be same, return type can also vary, that's not a part of the identification of the definition. Actually the parameter list becomes the factor, the criteria which actually helps the compiler to decide the definition to pick for that particular call. Okay, so that is function definition. Now we can overload. Why it is called overload? Because we are giving additional load to the function. I mean additional set of alternate definition. Okay, so you can have as many alternate as you want and overload that function. The only requirement is parameter lists has to be unique for each of them. We can overload a global function like sort array. Okay, and we can have many definitions with integer array parameter, float array as parameter, and so on. We can also overload member function or method of a structure or class. Okay, so it is not exclusive to global function. You can overload any function or method. So in this video, if I say function, I mean global function. If I say method, then I mean it's a member function. I have already created a C++ project, and there is a by default main function. So let's create some global functions called find largest. Okay, so let's say void find largest, and I'm going to provide an integer reference to an integer parameter. So int, let's say arr, or let's say okay, arr, and of course I have to provide the size of the array. So let's say int as. Okay, and we will print the largest value. Okay, so let's run a loop. So we have declared a temporary variable largest, and we are assuming that the first element of the array is the largest. So now we can run a loop from the second element. So for I equal to 1, I less than size, which is s in this case, I plus plus. And now if the array ith element of the array is greater than largest, then we change the largest equal to the ith element. Okay, so that is pretty much the function. And now after the loop is over, we need to print that function. So cout the largest element is largest. Okay, so we now have only one version, which is which can actually find the largest from an integer array and print it. Okay. Okay, so or I can change the name, let's say show large or display largest. Okay, so display largest. Now in main function we will declare an integer array. So let's say int arr equal to, let's say 11, 22, 33, 44, 55. So we have 5 elements, and now we are calling display largest function with the array name, which is int arr, and the size is 5 because we know there are 5 elements. So if we build and run this, we see that the largest element is 55. So no issue, it's a very trivial program. Okay, now what I'm going to do, I'm going to declare another array of floats or double, whatever you want. Okay, so let's say double. So double, now the array name is double arr. Okay, and now again I am providing some value, let's say 1.1, 2.2, 3.3, 4.4, 5.5, 6.6. Okay, so that is the double array, and now I am calling the same display largest, the same function, but now the parameter is double array. Okay, okay, and we know that there are 6 elements. And now if we compile and run this, the first call here, the display largest, where the parameter is integer array, it will execute the integer version, and for the second call where the parameter is double array, it will execute the double version, the second definition with the double array as parameter. So let's provide another definition with reference to double array and overload this display largest function. Okay, so now I change it to double. Okay, that's all. So now the largest also will be a double, so I just change the type here. So now I have 2 definition. Okay, so this is one set of definition, and this is another alternate set of definition. Depending on the call will be analyzed by the compiler to decide, to make a decision which definition to execute for this particular call. So for each of the calls of an overloaded function, the compiler looks at the call and make a decision which definition will be executed for that particular call. So if we now build and run this code, then we'll see that the largest element is 55 for the first call, which actually where actually the integer array was the parameter, and for the second call the largest element is 6.6, where the double array was the parameter. So that is actually function overloading. Now let's overload a method. So let us create a class. Okay, so class student. Okay, and now let's say we will have actually let's say 3 fields. So integer id, then string name, okay, float CGPA, okay. Okay, so now maybe there is a department, so let's have another string, let's say department, okay. Okay, so fields are private, so to access manipulate this private field we should have some public methods, okay, member functions. So let's have a method to populate the fields for an object. So let's say void set stud info. So it will set the student information, and here we can actually take the user input. So we are asking for ID, okay, and the ID is given by the user. Now name might contain space, so therefore we need to use getLine and ignore the flash out the previous slash and null character from the stream buffer. So now we are asking again what is the name of the student, okay. Okay, and then we are using getLine, so the name is taken, and finally also the department. So since the name is a string, so we don't need to ignore for department because that's the next immediate input. So department, okay, so we are also taking the department, and finally we are asking for CGPA, okay. So enter CGPA, okay. So that is the method to take input for the fields of an object of type student, okay. I'm not going to overload this method. I'm going to overload the viewing method, that is to display the field values, okay. So now for that purpose, let's say we'll have another method called ShowStudentInfo, okay. So void ShowStudInfo, okay. And I'm going to, now you see this ShowStudInfo, this particular version has no parameter, so it will display all the fields, okay. So cout, let's say ID equal to the value of ID, then name equal to the value of the field name, and then department equal to the value of the department, and finally the CGPA, okay. So CGPA equal to the value of CGPA, okay. So pretty straightforward, nothing complicated. So we have two public methods. One is to set the field values of a student object, and another is to display the or show the field values of a student object. So now let's create, so let me comment this global function version, okay. So now let's declare an object. So student, let's say John, okay. So John, we are taking input for John, so we are calling set studinfo, okay. And we are also immediately after that we are calling the ShowStudinfo method, okay, to show the field values from the object John, okay. So if we execute this now, so in ID. Okay, so there is a typo mistake. Okay, anyway, yeah. So now if you see, I think the again typing mistake. Okay. Okay, so it is asking ID for John. Let's say 1, 2, 3. John Smith. Department, let's say CSE, Computer Science and Engineering. Let's say CGPA 3.56, and it is displaying the field values of John. So now nothing is overloaded. Now let's say we want to overload the show student info with another definition and parameter. Now this will not be compiled because both has 0 parameter, so which is same, parameter list is same, therefore compiler is objecting. So if we change the parameter list, let's say int or let's say boolean all, okay, or let's say is CGPA to be shown. So there is a boolean parameter now, is CGPA to be shown. So if this is true, then it will show CGPA along with other field values, because CGPA may not be necessary every time you want to see a student information, okay, or there the programmer might decide to have an option where it can exclude the CGPA. Okay, so if you don't put any parameter, it will print everything. But if you put a boolean with false with true value, or is CGPA to be excluded, okay, so let's say, okay, then it will actually exclude the CGPA, okay. So let's say we have a boolean in main. Now we have two different versions. One is without any parameter, another is with a boolean parameter. So in main, let's say we have a boolean is CGPA to be excluded equal to, let's say, true, okay. So that means now if we pass this while calling the, again now we are calling John dot show student info, but this time we are sending a boolean as a parameter. So now you see, now we are calling the show student info where John is the client and main is the caller. Now compiler can decide which definition to choose. Now compiler see this call is made with a boolean parameter, so it will call the boolean version, okay. And the previous call, the show student info was called without any parameter, so for this previous call it will pick the definition without any parameter, okay. Now if you compile, it will be successfully built, okay. So I can let's say I can say B, okay, so boolean B, or let's say boolean flag, whatever you want to call it. Now depending on the flag value, we will print CGPA or not, okay. So if let's say not flag, so that means if it is false, then we can actually print everything, okay. But we can also say printing all values, okay. So let's say showing all fields, okay. If not, we are actually showing only the fields other than CGPA. So we are excluding CGPA, okay. So we can say so we are not showing all fields, so rather we are showing only ID, name and department. Okay, so this is actually the overloaded version. So we have two version of the method ShowStudentInfo, one without any parameter, another with a boolean parameter flag. So we are checking the flag. If flag is false, then it means we are not supposed to exclude the CGPA, so it is showing all of them, all the fields. On the other hand, if the flag is true, it is showing the fields without CGPA. So now if we execute the John.showStudentInfo without parameters, it will show all the fields, and John.showStudentInfo with a boolean parameter which we assume as true, so that means it will exclude the CGPA. Okay, so let's run it. So it is asking ID. Okay, so let's say 1 2 3 John Smith 3.57. Oh sorry, I made a mistake. Department should be a string. So run again. So ID 1 2 3, name let's say John, department let's say CSE, CGPA 3.57. Okay, and for the first call of ShowStudentInfo, it is showing all fields. Okay, and for the second call, it is showing only the fields other than CGPA. Okay, so that is actually method overloading. Okay, now if we give the boolean as false, then what will happen? So let's say we have another object. So let's say other than John, let's say Raju. Okay, so we also call set StudentInfo for Raju, and this time we call ShowStudentInfo of Raju, but sending the boolean as false. So we can directly give the literal false. Okay, we could also directly give the literal true here. Okay, so it means it will print all the values, but not executing the zero parameter version, but by executing the bool parameter version. But so additionally now it will tell showing all fields. Okay, so that's the whole point. So let's run it again. So now this is for John. So ID let's say 111. Okay, let's say John Smith. Department CSE, CGPA 3.55. So it is showing the zero parameter version, showing all fields, and the boolean version where the true value is given, so it is excluding the CGPA. Now it is asking input for the second object Raju. So let's say 222 Raju Nirola, for example. Department let's say EEE. Okay, CGPA let's say 3.65. But now while calling the ShowStudentInfo, Raju.ShowStudentInfo, where Raju is the client, the false was given as parameter. So again the boolean version will be called, but because of the if else, it will print all the values with the additional text showing all fields. Okay, so that is actually method overloading. So I hope it helps. Basically, function overloading or method overloading does not make your execution faster. Rather, it's a tool. It provides convenience. Okay, to the programmer. If you like this video, please give a thumbs up and share with your friends. And thanks for watching. See you in the next video.